Alright everyone, hey, I just wanted to work through a few questions with you all from chapter 3H. We're going to work through worked example 18, and then we're going to work through question 2 from the exercises. So to start off, we're going to be looking at a bit of a question from the worked example. So just this one here, I'll zoom out a little bit. It's a little bit confusing to start off with, but I wanted to sort of go through each step and how I would tackle every single one. Hang on, let me just get my pen out today. So we're first going to look at our question, which was if y is equal to a over x plus b, and it goes through these points, what is a and b going to be equal to? So the first thing I'd want to do is I'd actually want to substitute in my x and y values from these points. So x is equal to 1 and y is equal to 5, and then I've just simplified that here to be 5 equals a plus b. And then same here, I've got 4 and 2, and so I've just substituted those 4 and 2's in. And what we can do from here is we can actually treat this like a simultaneous equation so that we can solve for a and b. And I'm actually just going to take this equation and I'm going to take away this equation from this one. So it's going to be 5 minus 2 equals 3, a minus a over 4 equals 3a over 4, and b minus b, now I accidentally wrote it here, but we'll just get rid of that b altogether. From this, I can see that 3 is equal to 3a over 4, which means that 12 is equal to 3a, and a is equal to 4. Awesome, we're already halfway through this equation already. We just need to now substitute it back into our original one, which means I can turn back to these equations here to find b. Now, I could use this equation here, but because this equation looks so much easier, I'm actually going to substitute my value for a into this one. And what did we say a was? A was 4, so 5 equals 4 plus b. Now I've written that here. 5 equals 4 plus b. B must be equal to 1. We've pretty much solved most of our equation. All we need to do is substitute our a value in and our b value in, and that's going to give us our answer. So y is equal to a, which is 4, over x, plus 1, which was our b value. And that would be my answer today. This week, what I want you to do is work through a few questions. We've got chapter 3H, and I want you to work through questions 1, 2, 3, and 4. If you would like to, I would like you to also have a look at the extension, which is 5, 6, and 7. 5, 6, and 7 kind of take the concepts of 1, 2, 3, and 4, but instead of being a nice sort of hyperbola that we have here, it sort of brings it to be more of like a truncus, or even to the power of 3 in different circumstances, like this one here, and then the cube root instead of the square root. I want to quickly work through question 19's fairly similar in the sense that we find our x and y, well, we substitute in our x and y value and it gives us this answer. We then substitute in our other x and y value and it gives us this answer. From there, we can actually just sort of go through and subtract one from the other, which gives us a value of a is equal to 5 on 2, and then substitute in to find b, and finally that would give us our final equation. It's a little bit confusing. I'll get you to get a bit of a read through that. One question that I wanted to go through with you today, which is in the class. Now, I'll give this one a bit of a try first, but the graph shown has the rule y is equal to a over x plus b plus capital B. It's a bit confusing that they use b twice, but we just have to keep track of when we're using capital and lowercase b for this one. And if I sort of zoom out a little bit, you can see that we've got this one here. We've got x is equal to 1. So our, what's it called? Our vertical asymptote is where x is equal to 1, and our horizontal asymptote is where y is equal to 2. And we've got an intercept that's listed at 0 and 1. Alright, so let's go through how I'd solve an equation like this. So we've got our graph there that I've drawn up. I'm going to probably first look at this y here. Now, usually when we have a vertical asymptote for our hyperbolas, when it's equal to 0, it goes across our 0. So I can kind of see that my graph has been shifted up 2 spaces, and so I've just put a +2. In the same way, I can see that my graph has been shifted horizontally one space. So at the bottom here, I've then taken another step. Now remember, we have a -1 instead of a +1, and I can actually work that out because I know that this is going to be a vertical asymptote. 1, if x is equal to 1, and this is going to have to be equal to 0 for it to be a vertical asymptote. So that's where that one comes from. So we've already got that I know that that one of our values, I think that was capital B, is equal to 2, and our other value is equal to -1. I think that was lowercase b there. Now we just need to solve for a. What I'm going to do is I'm going to take the one point that I know from this and substitute in my x and y values. So x is going to be equal to 0 and y is going to be equal to 1. We can do a little bit of rearranging. We get -1. Remove the 2 across the other side, we get -1. 0 minus 1 is also -1, so -1 is equal to a over -1, which then just means that a is equal to 1, which gives us our final answer if we substitute all those things in. So we've got a equals 1, then capital B was equal to 2, and lowercase b was equal to -1. That gives us the equation of y is equal to x over -1 plus 2. X over 1, y is equal to 1 over x minus 1 plus 2.